In this video, we're going to look at how to sketch the graph of a polynomial function, right? So it's very similar to how we sketch the graph of a quadratic function, right? So what do we need? Well, we don't really have a vertex here. So what we need here is obviously we need the points of, we need the x-intercepts and y-intercepts as the points where the function crosses the x and y axis. I need to know the end behavior. That'd be very helpful. And then I need to figure out if there's a symmetry, right? Symmetries are always good because if I have a symmetry about, say, the y-axis, I can draw one half and then just go ahead and figure out what the other half is, right? And then I need to figure out when is my graph going to be above the x-axis, when it's going to be below the x-axis. That'll be very helpful as well, okay? So we're going to go ahead and start first with the end behavior, right? So I have step 1, and that's going to be the end behavior. Okay. So for my end behavior, again, I look at my leading term. What's my leading term? And my leading term is negative x cubed. Okay. So in this case, as x approaches infinity, y is going to approach negative infinity. And as x approaches negative infinity, y is going to approach infinity. All right. Because n is odd and a is negative. All right. Now, let's go ahead and find the intercepts. So as we all know, we have two intercepts, right? We have the x-intercept and y-intercept. So let's go ahead and find the x-intercept. Okay. So I know that for the x-intercept, I'm going to set y equal to 0. Okay. And so I have negative x cubed minus 4x squared plus 4x plus 16 equal to 0. If you go ahead and factor this, I'm going to get negative x plus 4, x plus 2, x minus 2 equal to 0. Now, how did I factor this? That'll be a question for the quiz. Okay, so we get x equals negative 4, negative 2, or positive 2. Right? So my x-intercepts are negative 4, 0, negative 2, 0, and 2, 0. So I have three x-intercepts in this case. Okay. How do I find the y-intercept? Well, set x equal to 0. So what I get in that case is I get f of 0 equals negative 0 cubed minus 4 times 0 squared plus 4 times 0 plus 16. And so everything here is 0 except the 16, and so that's going to be 16. So my y-intercept is going to be 0, 16. Now, since it's a polynomial function, we're going to try and figure out what if it has a symmetry. Remember, if you remember from chapter 1, we have two types of symmetries when it comes to functions. You can have symmetry about the x-axis. Sorry, you can have symmetry about the y-axis, or you can have symmetry about the origin. Okay? And sometimes you may have no symmetry at all. So does this have any of the symmetries? Because if we have symmetry, it's really easy to draw the function. Okay? So let's look at symmetry. So step 3 is symmetry. Okay, so what do we do here? We take f of negative x, and that is going to be negative of negative x cubed, all right, minus 4 times negative x squared plus 4 times negative x plus 16. So basically what I did was I replaced all the x's by a negative x. What do I get? I get this is, well, this is negative x cubed, so that'll be positive x cubed with the negative sign there. This will become positive x squared minus 4, and negative 4 times positive x squared is minus 4x squared minus 4x plus 16. Well, is this the same as the other function? No. So we know that f of x is not equal to f of negative x, okay, which means no symmetry about the y-axis. Okay, And to check for symmetry about the origin, we need to figure out what is the relationship to f of x. Is that equal to negative f of x? So basically, did all the signs change? Well, let's see. X cubed changed signs. Negative 4x squared did not. So 2 of the terms changed sign, 2 of them did not change sign. So this is not true. Okay, and so there is no symmetry about the origin. Okay, so now we've figured out what was this, if there was symmetry, and figured out that our function has no symmetry about either the origin or the y-axis. We found our x-intercepts and we found our y-intercept. We found the end behavior. Now we're going to do something that we did not really see when we graphed a quadratic function. But if you remember the very first class we did when we worked with inequalities, we made like a sign chart. And that's precisely what we're going to do here. So we're going to make a sign chart here. Okay, so I'm going to take all my x-intercepts and I'm going to plot them on this number line. So I had negative 4, negative 2, and positive 2. And then I'm going to write all my factors here. So I had negative x plus 4, I have x plus 2, and I have x minus 2. Okay, and then I'm going to write down my actual function in factored form, and that was negative 4, x plus 4, x plus 2, and x minus 2. Okay, so now I'm going to pick test points, right? That means, first of all, I've divided my number line into 4 sections. So everything less than negative 4, between negative 4 and negative 2, between negative 2 and 2, and then greater than 2. Okay, so in each of these regions, I'm going to pick a test point. Which point do I pick? Whichever I want. So I'm going to pick negative 5 here. You can pick negative 10 if you wanted. I'm going to pick negative 3 over here. I'm going to pick 0. And then I'm going to pick 5. Okay. What I'm going to do now is I'm going to take this negative 5 and put it in place of x. All I want to do here is figure out the sign. I don't need to know what the answer is, just the sign. So if I take in negative 5, put in negative 5 plus 4, that's a negative number, right? That's negative 1. And negative 1 times negative is going to be a positive 1, so the sign is going to be positive. Okay? If I take in negative 5 here, negative 5 plus 2 is going to be a negative number. And if I take in negative 5 here, negative 5 minus 2 is also going to be a negative number. Okay? So now, look at this column here. If I multiply all these signs, what do I get? I'm going to get a positive number, right? Because I'm multiplying 2 negatives, that gives me a positive, times a positive is a positive. Okay? I'm going to do the same with my other test points. I put in negative 3, that gives me a negative number. This gives me a negative number. That gives me a negative number. So I'm going to get a negative because I'm multiplying 3 negative numbers. Okay? With a 0, this is going to be negative. This is going to be positive. It's going to be negative. So I'm going to get a positive number again. And finally, with 5, it's going to be negative, positive, and positive, which eventually will give me a negative. What that means is, here, my function lies above the x-axis. If I see the negative, that's where my function in that region lies below the x-axis, above the x-axis, and again, below the x-axis. Okay? So let's go ahead and graph this function. So my next step is to graph. Okay? Now, so here's what we recap from the previous slide. We have our end behavior. Our x-intercepts are negative 4, negative 2, and 2. Y-intercept is 0, 16, and there is no symmetry. Okay? So let's go ahead now and graph our function. Okay? So I'm going to say this is 5, 10, 15, and 20. Negative 5, negative 10, negative 15, and negative 20. And then I have 1, 2, 3, 4, 5, negative 1, -2, -3, -4, -5. Okay, so I'm going to go ahead and graph my intercepts first. So my intercepts are -4, 0. I have -2, 0. And then I have 2, 0. All right. And then my y-intercept is 0, 16, which would be somewhere around here. Okay. Now the question is, does my function go this way or does it go this way? We don't know that, right? So that's where I refer back to my sign chart. So it says that anything less than -4, my function is over the x-axis, and then once I cross -4, I go negative, right? So basically, I'm going to be above the x-axis to the left of -4. I'm going to come down. Once I cross -4, it's going to be below the x-axis. Once I cross -2, it'll be above the x-axis, so on and so forth. So my function is going to look something like that. Okay, and that would be the graph of my polynomial function, -x³ minus 4x² plus 4x plus 16.